Good morning. Today we are continuing on with CO58, working with those polygons. We are going to determine whether polygons are congruent, similar, or neither. So we worked with polygons in yesterday's objective, being able to identify them and classify them. Now we're going to determine if they are congruent, similar, or neither. Who can tell me what that math vocab term of congruent means? Jack?
Like equal.
Equal, identical, they are the exact same. Okay, so a congruent polygon are polygons that are the same shape and size. All sides and angles are congruent. So the big thing you need to remember for congruent polygons are they the same shape, same size. Okay? Congruent means same shape, same size. So let's look at an example of this. So let's say we have this shape and this shape. This is labeled A, B, C, and D. This is labeled X, Y, W, X, Y, and Z. Okay? Now, it says list the pairs of corresponding sides. If they are corresponding sides, they are the ones that are congruent. So, A and B is congruent to that WX. BC to XY. Then we have CD to YZ. And we have AD to WZ. So those corresponding sides are the sides they match up with. Okay? They are the same. So when they all correspond with each other, they are all congruent. It is a congruent polygon. Now, a similar polygon are polygons that are the same shape, but different sizes. So their angles are congruent. And their sides are proportional. So that means every side's getting bigger or smaller at the same rate. So you're multiplying each side by 2. You're dividing each side by 3. They are the same proportion for every side. So big thing to remember for similar polygons is that they are the same shape, different size. Okay. Same shape, different size. Now examples of this. Can you guys see if I leave it down here, or do you want me to scroll up? Is it easier to see if I scroll up in the back? Okay, so I'll erase this. Let's look at examples of those similar polygons. So we might have a triangle that looks like that, and one that looks like that. So we have A, B, C, X, Y, Z. Then we have, remember, those arcs that show congruent. A is congruent with X, B is congruent with Y, C is congruent with Z. Okay, so we know their angles are the same, but their size is different. Does that difference in size, is it proportional? So let's say this is 18, or 8, 14, and 18. That side is 4. It's corresponding side. I think I said that wrong before. I said corresponding sides are congruent. Sorry, I was going too fast. Corresponding sides are the sides that match up. So AB corresponds with XY. It's either congruent or similar to it, right? It's going to be the side that you match it up to. It doesn't have to be congruent to be corresponding. So I made that mistake. So if you wrote that on the top where it said corresponding sides, cross off congruent. They don't have to be congruent. You just have to know that's the side that you're matching up and looking at. Okay. Not corresponding does not mean congruent. It did for a congruent polygon, but when we're looking at similar, they don't have to be congruent. But AB matches up with XY. If it is proportional, what do you think YZ is going to be? Rhoda? What measurement would it be? If BC is its corresponding side, what measurement would YZ have to be if it is proportionate? What do you think, Alex?
7.
How did you get 7, Alex?
Because 7 is not 14.
8 to 4, I divided by 2. So that means 14 to 7, I'm dividing by 2. So if it's proportionate, I'm going to divide by 2 for every side. So what does XZ have to be if it's proportionate? Haley? 9. 9, because 18 divided by 2 is 9. So if it's proportionate, you're going to either divide each side by the same number or multiply each side by the same number. So the corresponding sides here, we have AB corresponds, so we're not going to put the equal sign there because they are not equal, but it's similar to, proportionate to XY. BC is proportionate to YZ, and CA is proportionate to ZX. Now, it's easy to know if two polygons are congruent. They have the exact same measurements. They look the exact same, right? Congruent's the easy one. Similar, we have to determine if it's similar. So we have to do some math. We have to prove that they are proportionate. So what I would do is I would take the corresponding sides. AB over XY, YZ over, well, BC over YZ, sorry. And CA over ZX. So that would be saying 8 over 4, 14 over 7, 18 over 9. What operation am I going to want to do with those fractions? What does that fraction bar tell me to do, Joy? Division. So I'm going to divide my corresponding sides. 8 divided by 4 is 2. 14 divided by 7 is 2. 18 divided by 9 is 2. I am proving that they are proportionate. Every side corresponds with the other polygon. They're all divided by 2. It is proportionate. You have to match up all those corresponding sides and do the math for each one to make sure that it's all divided by the same number. If it is not divided or multiplied by the same number, then it would be a neither. It's not congruent and it's not similar. Because we can have two triangles. They're both triangles, but they are not congruent. They are not similar, right? So we have to prove that something is similar. We have to show the math that those corresponding sides are all proportionate. So let's look at the bottom here. It says determine whether the polygons are congruent, similar, or neither. Explain how you know. That's doing the math. Okay? So you have to show if they are similar or neither, you're showing that math. If they are congruent, you're going to show that they are identical. So let's look at our two examples. So this is our first set. We have to determine congruent, similar, or neither. This is our second set. So let's look at our first one. Are they congruent?
No.
How do you know it's a no? Fernanda?
Because the second one is smaller.
Yeah, different size. They have different measurements. We know it's not congruent. They're not identical. So now we have to determine if they are similar. So we have to match up those corresponding sides. So we have this long side to this long side. So I'm going to say 12 over 4. Then we have this long side to this long side, 15 over 5. And we have the short side, 9 over 3. What math do I have to do to those fractions? Rhoda? We have to divide. What is 12 divided by 4? 3. What is 15 divided by 5?
3.
What is 9 divided by 3?
3.
Are they all the same?
Yes.
Yeah. I divided each side by 3, so it is proportionate. So what should I write? Congruent, similar, or neither? Jackson?
No.
Similar, because they all the sides divided by 3. So it is similar. Let's look at our next one. Look at how my shape is flipped. You have to take that into consideration when we're matching up corresponding sides. Because I see this short side here, and then I see a long side on top. Are they corresponding? We need to make we need to flip that shape so we can match up corresponding sides, right? Looking at it this way, this does not correspond with this. This corresponds with the short side over here, right? Short side to short side. So I have a 6 over a 6. Well then, if I had to flip it down to match it up, that means this long side corresponds with this long side, which is 22 over 22. And then my slanty side matches up with my slanty side, 19 over 19. And this slanty side matches up with this slanty side, so that's another 19 over 19. Do I have to do the math on this?
No.
Why not?
Because you're dividing the same number on the.
Because all the numbers are the same. 6 divided by 6, 22 divided by 22, 19 divided by 19, 19 divided by 19. If the numbers all are the same, what can I say about my two polygons, Alex?
They're congruent.
They are congruent. So if, when you match them up, all of those corresponding sides are the same number, you know it's congruent. But this is proving it. So when it says explain how you know, That's how we know the numbers are the same. Jack?
Just have a question.
Yeah.
Could, two shapes be similar and congruent?
So that's like a square is a rectangle. But a rectangle doesn't have to be a square, right? A rectangle has those 4 right corners,
Yeah.
2 short, 2 long sides, whereas a square has those 4 right corners and the sides are all the same.
Yeah.
So a congruent is automatically similar. Similar is not automatically congruent, right? Does that make sense?
Yeah.
So it's proportionate because there it goes down to the 1. So it's just a special kind.
Sure.
All right, let's look at our work page. Well, I take that back. By definition, similar is same shape but different size. So no, congruent cannot be similar because it's same size.
Yeah, so it's never both.
It's never both. It's not that congruent is a form of similar. I'm going too fast because it's a short class today and I needed to stop and think. No. Congruent by definition is same shape, same size. Similar, same shape, different size. So it's one or the other, or neither. All right, so now it says draw and label each pair of figures. Make your figures as accurate as possible. So, if I want to draw congruent polygons, I'm going to use an easy type of polygon to draw. I'm not going to draw like an octagon and try to figure out 8 sides and then 8 sides. Keep it simple. I like my triangles. If they are congruent, what should my second triangle look like as I draw it? Moses? If it's congruent, I'm going to try to make it look identical, right? Am I going to be perfect? No. What do I do so people will know that it is congruent triangles? Rhoda? I can put notches showing that those sides are all the same, right? The corresponding sides are congruent. Or I can do measurements. I could say this is a 5, that's a 5, this is a 6, 6, 7, 7. I can somehow show that my corresponding sides are the same, either with the notches or with the number measurement. So if I'm going to do similar, let's say I do that same triangle, what would I make a similar triangle look like? Fernanda?
One would need to be smaller or bigger than the other.
One would need to be smaller or bigger than the other, but I'm going to try to make it look same shape. So it can't be any triangle. It has to be a triangle that looks the same shape. So let's say I put my measurements as 8, 6, and 4. What could I put as my measurements for the other triangle if they are similar? How can I show that they would be similar? What do you think, Joy? Why did you pick 4, 3, and 2, Joy? She divided it by 2, each of those sides. 8 over 4, 6 over 3, 4 over 2. They're all divided by 2. They are proportionate, they're similar. So when you're doing your similar shapes, pick easy measurements that you can either divide or multiply by the same number. So if you're going to label these figures, you have to label it accurately. What about neither? What am I going to make that second triangle look like if it says neither? What can can I make that second triangle look like? Who wants to come up and show me what a triangle might look like? Fernanda, come on up. Ah, she drew a triangle, but it looks very different. Not the same shape, not the same size. Now I need to prove it. So I'm going to label, so let's do that 5, 6, 7, and maybe I would do this as 12, and maybe this as 7, and maybe this as 5. Those sides don't correspond. They are not proportionate at all. So you need to show me two shapes that are totally different. Does that make sense? Okay, so the rest is going to be your work. Determine whether the polygons are congruent, similar, or neither. Explain how you know. Don't trust your eyes. The figures may not be drawn to scale. You must match up those corresponding sides, divide those fractions down, and see if each side divides down to the same number. Sometimes it's a whole number, sometimes it's a decimal, but that decimal needs to be the same for every side. So you're gonna match up corresponding sides, so this is 12 over 19, 11 over 16, 9 over 14, and then you're gonna divide it down and tell me what each of those fractions are going to equal. If it's the same decimal or whole number, then it is similar. If it is not the same decimal or whole number, then it is neither. If the numbers had been identical, then it would be congruent. At the bottom, it is time for review. Refer back to previous objectives to see if, to answer those questions if you don't remember those words. Remember, Khan Academy is due tomorrow. Packet number 9 due on Friday. When we come back from spring break, tomorrow is our last objective of the unit. So when we come back, we're gonna have a review day, because a week off for spring break is a lot. So we're gonna come in prepared to review. Practice test will be that Tuesday. Real test will be that Wednesday after spring break. Okay? So just know when we come back, we have to be ready for all of that review. This Friday is a retake day. So if you have practice works you need me to correct, make sure you're turning them into the blue tray. Any questions? Okay. If you are watching at home, I hope you are well, and I hope to see you soon. Have a wonderful day.